everyone. Today I'm going to teach you Easa Module 1 Mathematics Practice Lesson 1. So in this lesson, I'm going to teach you the arithmetic. In this lesson contain introduction, arithmetic terms, direct numbers, factors, arithmetical procedures, fractions, decimal fractions, weight and measures, ratio and proportions, averages and percentages, powers and roots. Okay, so you can go through this video and then you can get a rough idea for the Easa module exam. So this is I made these lessons to for you to understand about module 1. Then you can see this video and then you can study your own notes. Then you can face your module 1 examinations successfully. All right, so now let's go to the lesson. So in the first one, introduction. The foundational language of all mathematics is arithmetic, right? So which employs real non-negative numbers. These are occasionally referred to as counting numbers. Addition, subtractions, multiplications, and divisions are the only 4 operations used. While you are familiar with these operations, nonetheless, a review of the words and procedures utilized will facilitate learning of the more challenging mathematical ideas. All right. Okay, so now first go to the arithmetical terms, right? The decimal system, which uses the 10 digits 0 to 9, it means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is the most widely used system of numbers, right? So integers are the 10 whole numbers ranging from 0 to 9. The numerals are repeated in various ways above the number 9 to indicate bigger numbers. The numbers are arranged in columns depending on a multiple of 10 to achieve this. For integers less than 0, a negative symbol is added to the number, right? It means if the integers are less than 0, we will add negative symbol, right? Example, -1, -2, -3, like this. Fractions are used to represent quantities that lie between whole numbers. When areas between two integers is divided into equal parts, such as quarters, common fractions are applied. Decimal fractions are often used when the interval between integers is divided into 10 segments. All right. So the students will be familiar with these systems and the basic operations, which may involve addition, subtractions, multiplications, and division. All right. So when numbers are added, they form a sum, and when the numbers are subtracted, they create a difference. And when the numbers are multiplied, they form a product. And when the numbers, the dividend is divided by another divisor, the result is quotient. All right. Okay, so it is helpful if a learner is good at basic mental calculations, and this is only possible if one has an emotional sense of numbers and their sizes. Understanding basic timetables is also helpful. So you can go through this timetable. So let's see, the following simple test for divisibility by may be useful, right? So example, a number is divisible by 2 if it is an even number. A number is divisible by 3 if the sum of the digits that forms the number is divisible by 3, right? So a number is divisible by 4 if the last 2 digits are divisible by 4, and a number is divisible by 5 if the last digit is 0 or 5. Right, and the number is divisible by 10 if the last digit is 0. All right, so now let's go to the direct numbers. So any number that has plus or minus sign next to it is said to be directed or direct numbers. Example, we are going to take example +1, -1, or +2, -10. These are the direct numbers. So directed numbers can be added, subtracted, multiplied, divided, etc. So but quotient should be used to get an accurate result. The guidelines below should be helpful. All right, so the first one is when adding multiple numbers with the same sign. Example, +1 +1 or +1 +9, same sign. Make sure the sign of the sum matches the sign of the individual numbers, right? So then subtract the smaller number from the bigger one to add 2 numbers with different sign. The resultant, the difference sign is identical to the bigger number sign. Now this one is just you can see like -12 plus 6. So then we have to add. So right, we have to add +12 -6. So we have to take it minus here. Then the answer is 6, but in the sign should be the sign equal to the biggest number. So in here, the biggest number, the sign equal to the biggest number is minus. So the answer should be -6. If there are more than two numbers, work with two at the time or create two by adding all the numbers with the same sign, then use the above guideline. All right, there are two methods. So the first method, -15, we can add one by one like this. -15 minus 8 equal -23. Then -23 will be added to +13. Then the answer should be, my answer is -10. Then -10 minus 19. Then the -29. 29 plus 6 is -23. All right, the other way is -15. First, we will add the minus numbers. So -15 plus -8 plus -19 is -42. And then add plus numbers, +13 plus 6 equal +19. So then the answer is -42 plus 19 equal -23. Right? So I think you can get an idea about this one. All right. So then change the sign of the directed numbers to be subtracted, then add the resulting numbers. Right? So then change the sign of the directed numbers to be subtracted. Right? Example, if you change the sign of the directed numbers to be subtracted, then add the resulting numbers. Example, -10 minus -6. Then we have to change the sign. So minus into minus plus. So -10 plus 6. So the answer should be -4. Then 7 minus plus 18. So minus into plus is minus. So 7 minus, there should be 18. So the answer is -11. All right. In multiplications, positive is the result of two numbers with similar sign. Example, plus into plus is plus, whereas negative is the result of two numbers with opposite signs. Example, see, the resultant quotient is positive when two numbers with similar sign patterns are divided. The quotient is negative when dividing numbers with opposite signs. See, plus into plus equal plus, plus into minus is minus, minus into plus is minus, minus into minus is plus. All right. Okay, so now we'll go to the factors. We all know that 2 multiplied by 6 equal to 12. All right. And the factors of 12 are 2 into 6. We may also say that 3 into 4 are factors of 12 because 3 into 4 equals to 12. Likewise, 1 into 1. All right, example. So, although it may seem simple, it can occasionally be helpful to factorize or identify the components of the number. Finding an algebraic expression's factors is a more common condition. So, example, find the possible factors of 60. In other words, find the integers that divide into 60. So the factors will be 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30, and 60. All right, so you can check it out when you have free time. So now let's go to the prime numbers. Right, the prime number is one that has just two factors, 1 and itself. Example, prime number. So you see 13, we cannot divide it by another one. So 13 is 1 into 13. So they have only two factors, just only 1 and itself. So the prime numbers between 1 and 30 are 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. So the prime numbers between 1 and 30 are 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Why? We cannot divide 23 by another number. So 1 into 23 is 23. So they have two factors, 1 and 23 only. So the factors of particular numbers can occasionally be expressed in terms of prime numbers. Let's return. The factors of particular number can occasionally be expressed in terms of prime numbers, right? The factors will be expressed in prime numbers. So let's return to the factors of 60 as an example. Using 4 and 15 as our two factors, 4 into 15 equals 60. But 4 has 2 and 2 factors and 15 has 5 and 3 factors. As a result, the expression for the number 60 is 2 into 2 into 3 into 5, which are all factors of the number 16. So here you can see 2 is a prime number and 3 also prime number, 5 also prime number. So why is prime number? 5 has only two factors, 1 and itself. All right. So now let's go to the highest common factor. The highest common factor is the biggest factor number that will divide it into numbers being examined. Suppose that we take three numbers, 1764, 1200, 2100 and 2940. The highest common factor of these numbers is 84. In some instances, you will be able to identify these values simply by looking at the numbers. In others, you will need to calculate it. To calculate the highest common factor, we must identify the factors of each number in terms of prime numbers. You can see 2. You can go through this picture, and we then select the common prime factors and multiply them together to produce the highest common factor in this case. So the highest common factors 2 is here, 2 into 2 1, 3 is here, and 7 is here, highest common factor. So the highest common factor is 84. Right, so now let's go to the lowest common multiple. The smallest number that each of the given numbers will divide it into exactly is known as the lowest common multiple of the group of numbers. The lowest common multiple can be calculated by multiplying all the factors that each of the individual integers has in common. Right, just remember lowest common multiple and highest common factor. So consider the previous three numbers 1764, 2100 and 2940 are and their factors. See, these are the factors as the before slide. So the lowest common multiple of these three numbers will be 2 into 3 in all. All numbers have 23, 2 into 2, and 3 into 3 in 1764. This one have 2 into 3, and 5 into 5 only 2100 this one have. So 7 into 7 this one and this one have. So into this one and this one have. So the lowest common multiple is 2 into 2 into 3 into 3 into 5 into 5 into 7 into 7. So the lowest common multiple is 44,100. Right, so you can go through this picture. Now arithmetical procedures. The sequence in which we do arithmetical operation is refers to as an arithmetical precedence. Sometimes it makes no differences what sequence we do things in. Think about the formula 2 plus 3 equal 5. Again, if we write 3 into 4 equal 12, as 4 into 3 equal 12, nothing changes, right? However, if I write 2 plus 3 into 4, what is the answer, right? In this situation, we can take in two sections, right? See, if we first add 2 plus 3, we will get 5. Then if we multiply 5 into 4, then the answer is 20. Alternately, multiply 3 into 4 is 12. Adding 2, we get 14. All right. So there should be a pattern, right? So we must first agree on the rules we will apply before we can agree on the solution. This teaches the subject of mathematical order best recommended by the terms of BODMAS. You have to remember the BODMAS, right? The term BODMAS stands for the order or the sequence in which we carry out our calculation. So BODMAS stands for B for brackets, O for off, D for division, M for multiplications, A for addition, and S for subtraction. All right. So now this is the example for how to use BODMAS term, right? So find the value of 64 divided by minus 16 plus minus 7 minus 12 minus inside the bracket minus 29 plus 36 inside the bracket minus 2 plus 9. So let's see how to use BODMAS. See, these expressions become, so in these equations we will remove the bracket first. So after we remove the brackets, we will have this one minus 4, right? 7 into 7, minus 4 minus 19, 7 into 7. Now we will divide. Okay, now we will divide, then we will get minus 4 minus 19 minus 49. So then we will first in this this is not the way. Sorry. First we have to remove the brackets here. When we remove the brackets, then this is the answer coming, right? See, 64, 7 minus 7 minus 12 equal minus 16. First, we have to solve this bracket, and then minus 29 plus 36. When we minus 2 minus 9. When we solve these two brackets, 7, right? So minus 16, right? Now then we have to divide. When we divide, right? 64 divided by minus 4, the answer is minus 4, and minus 19, 7 into 7 here. Then we will multiply, right? Then we will multiply this one. When we multiply minus 4 minus 9, then 7 into 7, 49. Then we will add. When we add, the answer is minus 23 minus 49. Then we will subtract, the answer is minus 72, right? So you can go through these BODMAS equations, right? So now we will go into the fractions. 0.5 is an example of a proper fraction, which is sometimes abbreviated as fractions. It means the same thing as 1 divided by 2. The numerator is the number above the line, right? If we have a like these fractions, this is the numerator. Oh, sorry, this is the numerator, and this is the denominator, right? So denominator is the number below the line. All right. So 5.75 is likewise a fraction, but is the improper fraction because 23 is greater than 4. It is usually expressed as 3 upon 4, right? 23 upon 4 is 3 upon 4, right? This is the improper fraction, right? Proper fraction. So this is 1 divided by 2 is a proper fraction, and this is a improper fraction, right? Okay, so adding of fractions. It is important to remember that only fractions with the same common denominator can be added or subtracted, right? So there should be a common denominator to add or subtract. So here 5 upon 1 plus 3 upon 4. So then we have to take the common denominator. How to take the common denominator? We have to multiply 4 into 1. So when we multiply 4 into 1, here should be 4, then here is 1, then we have to multiply 4 into 5 is 20, and 3 here is 4, then 4 is 4 into 1 is 4, so 1 into 3 is 3, so 20 plus 3 is 23 upon 4. So this is the way of adding fractions. If the denominators are not the same, the lowest common denominator must be determined, and each fractions must be expressed in terms of this value. Finding the lowest common multiple is basically the same as finding the lowest common denominator, right? I teach you before, right? So each fractions must now be expressed in terms of least common denominator after the least common denominator has been discovered. This is accomplished by multiplying the result by the numerator and dividing the LCD by the denominator, right? Okay, so now let's go to the subtraction of fractions. The basic process is quite similar to that used for the addition. Identify the least common multiple, convert the individual fractions, then instead of adding, subtract the numerators. There could be one significant difference, all right? So the subtraction also same as the addition, right? So first we have to find the least common denominator, then we have to solve the problem, right? So here are some exercises for you, so you can pause this video and then you can do this exercises, right? So now let's go to this one, multiplication of fractions. In general, these calculations are simpler to execute than additions and subtraction. Simply multiply the numerators together and multiply the denominators together, right? It is very easy than subtract and addition. So to multiply, you have to multiply numerators together and multiply denominators together. So convert them to mixed number or simply simplify as necessary. So see, 3 upon 4 into 1 upon 2 equal 3 into 1. We have to multiply the numerators first, and then down we have to multiply the denominators. So 3 upon 8. So division of fractions, we multiply and then invert the divisor. The number we are divided by to divide two fractions, right? So convert first into improper fraction, next multiply after inverting the second fraction, right? So 23 divided by 23 upon 4 divided by 11 upon 2. So then we have to make it into multiplication. When we make it multiplications, we have to invert this number. So right number we have to invert. So then 23 upon 4 into 2 upon 11. So here 23 upon 4 divided by 11 upon 2. And here 23 upon 2, 23 upon 4 into or multiply by 2 upon 11. So then we have to solve it as a normal multiplication equations, right? Okay. So now decimal fractions. Decimal fractions are those whose denominator is a power of 10, such as 100, thousands, or 10,000. An example of a decimal fraction is 3 upon 100. Usually, decimals are used to rewrite decimal. The use of decimal point make this process very simple. Consider the value of 0.03. Any fractions can be formed into decimal by dividing the numerator by the denominator, right? So any fractions we can make it as a decimal. How? By dividing numerator by the denominator. For example, 857 divided by 1000 equals 0.875. Long divisions was used to find it. All right, so addition and subtraction of decimal numbers. Now we are going to addition and subtraction of decimal number. The most important thing to remember while adding or subtracting decimal numbers is to keep the decimal point as a reference, right? So we have to keep the decimal point as a reference. You see when you add this one and this one, here is the adding, and then how many decimals are there? 1 2 3 4 5. So then we have to keep it decimal point into yeah, the answer is sorry, no need to keep take the decimal number decimal point. So when we adding, we have to keep the decimal point as a reference. So when we adding this one, the answer is 37.093. So the answer is this one. This is the normal way. So multiplications and division of fractions, multiplication of decimals is the same as long multiplications, except that the number of decimal places in the responses must equal to the sum of decimal places. This is the express that the number of decimal places in the response must be equal the sum of decimal places in the values being multiplied. All right. So here 6.24 into 3.128, when we multiply this one, the answer should be 1947509. So in here, how many decimal points? 1 2 3 4 5. So then we have to take it 1 2 3 4 5. So the answer should be 19.47504. So the first number has 2 digits following the decimal point, whereas the second has 3. As a result, the answer must have 5 digits after the decimal point, making it 19.47504. Division is the same as regular long division, but a straightforward guideline: do not try to divide by fractions. Again, make the procedure easy. To make the divisor whole number, multiply both the divisor and dividend by a power of 10. Move the decimal point to the right. Here, right, you can go through the division. See, division 3650 divided by 45.56. Multiply both numbers by because how many decimal points are there? 2. So this is we have to multiply both numbers by 100. So then 365,000 then divide by 4,556. So the answer should be here, right? So this is the way how we divide the decimal numbers. Now we are going to the weight and measures. Various weight and measurements are applied when maintaining an airplane, right? So when we have to weight the aircraft, we have to use various weight measurements, right? So most likely fuel capacity, tire pressure, temperature, and speeds are the ones that first come to mind. However, there are tons of others that you may experience as you move forward with your future lessons. First, the System International SI unit is currently the most widely used system in the aviation. With a few exceptions, the system, which is based on multiples of 10, has achieved universal acceptance. It includes a set of units that are generally recognized for length, meters. For length, we are using meters, mass, kilograms, and time, seconds, temperature, Kelvin, current, ampere, and light, candela. While not included in the basic SI ones listed above, there are a number of other units that are widely used and continue to use the metric system for calculations, right? So a conversion factor is necessary to convert quantity in one unit to a quantity in another. The quantity in the second unit is obtained by multiplying the quantity in the first unit by the conversion factor. For instance, imperial gallons must be multiplied by 4.546 to equal liters, right? So convert 25 gallons into liters. So then we have to multiply 25 into 4.546. Then the answer is 113.65 liters. So now let's go to the ratios and proportions. In aviation, ratios are frequently used for as when figuring out an engine's compression ratios, right? So this is the difference between the replacement of the cylinder when the piston is at the bottom of its strokes and when it is at the top. For instance, if the cylinder's capacity is 240 square centimeters at the bottom of its strokes and 30 square centimeters at the top, the ratio is 240:30, or expressed in the simplest form 8:1, right? Okay, so example, divide pound 240 between 4 men in the ratio of 9, 11, 13 to 50, right? So the normal procedure for this type of problem is add all the individual proportion to find the total number of parts. First, we have to add all these things. Divide the total number by the number of parts to find the value of each part. So multiply each ratio by the value of each part. See, 9 plus 11 plus 13 plus 15 equal 48. So then first we have to divide 240 divided by 48 equal 5. Therefore, each part is worth 5 pounds, right? So then 9 into 5 equal 45, 11 into 5 55, 13 into 5 65, 15 into 5 75. So the proportions are therefore 45, 55, 65, and 75. So the useful check is to add the individual parts together to ensure the total is the amount you started with, right? So now let's go to the averages and percentages. Averages, find the average value might be helpful when working with numerical data. Always use an average speed when determining the duration of specific journey. There is no point in basing the time on either the slowest or fastest speed in order to determine how much fuel an airplane will consume for a certain flight. We would also consider average fuel consumption. We can only determine the average in both of these calculations by dividing the total distance traveled or the amount of gasoline consumed by the time. Okay. Right. So example, an aircraft travel a total distance 750 kilometers in time of 3 hours and 45 minutes. What is the average speed in kilometers per hour? So then average speed, total distance divided by time. So the average speed is 200 kilometers per hour. So example 2, we can go an aircraft uses 300 gallons of fuel for a flight of duration 4 hours. What is the average fuel consumption? So then average fuel consumption is 300 divided by 4. The answer is 75 gallons per hour, right? So we often need to calculate averages based on many data items, right? So now let's go to the percentage. Percentages are fractions with a denominator of 100, right? Percentages are fractions with the denominator of 100. So decimal fraction 0.33 is comparable of 33% or 33%, and it is the same as 33 divided by 100. Common fractions can be converted to percentages by first converting them to decimal fractions and then multiply by 100. For example, 5 upon 8 as a decimal is 0.625. Right, which is converted to a percentage by shifting the decimal point 2 places to the right, which is equivalent to multiplying by 100. This is equal to 62.5 percentage. To find the percentage of number, multiply it by the percentage decimal equivalent. To find 10% of 200, for example, first convert 10% to its decimal equivalent, which is 0.1, divide the percentage amount by 100 to get is this. Now multiply 200 by 0.1 to get the number 20. All right. Okay, so to calculate the percentage of one number over another, divide the first number by the second and multiply the quotients by the 100. For example, an engine may produce 85 horsepower out of possible 125 horsepower. What proportion of total available horsepower is being developed? Divide 85 by 125 and multiply the quotients by 100 to solve this, right? So 85 divided by 125 equals 0.68 into 100 is 68% power. And another example of percentage is determining a number when only a portion of the number is known. For example, what is the maximum speed if 4180 rpm is 38% of the maximum speed? To find this, divide the known figure 4180 rpm by percentage decimal equal. Right, example 4180 divided by 0.38 equal 11,000 rpm maximum. Right. So powers and roots. Let's go to the powers and roots now. The powers, a number is said to be raised to a specific power when it is multiplied by itself. For example, 6 into 6 is 36, so hence the 6 to the power 2 equal 36. The number of times the base number is multiplied by itself is written to the right and slightly above the base number or an exponent. A positive exponent represents the number of times a number is multiplied by itself. All right. Example 3 into 3 to the power 2 is read as 3 squared or 3 to the power 2. Its value is found by multiplying 3 by itself. If there's power 3, you can multiply by 3 by 3 by 3, right? So 2 into 3 is read by 2 cubed, or 2 to the power 3, its value is found by multiplied by 3 itself 3 times. 3, 2, 2, 2. So 2 by itself 3 times, 2, 2, 2, so 8, right? So this is the powers. If the exponent is the negative integer, the minus sign denotes the number's inverse or reciprocal when the exponent is converted possible. So 2 to the power minus 3 is the same as the reciprocal of 2 to the power 3, which is 1 over 2 to the power 3. So 2 to the power minus 3 is reciprocals, right? So 1 over 2 to 2 equal 1 over 8. Any number other than 0 raised to the 0 power equals 1 when a number is written without exponent. The value of the exponent is presumed to be 1. Furthermore, if the exponent is not preceded by a sign plus or minus, it is presumed to be positive. Now let's go to the roots. The root of the number is the value that produces that number when the multiply by itself, specific number of times. For example, 4 is the root of 16, hence the product of 4 multiplied by itself is 14. 16. So 4 is nevertheless a root of 64 because 4 into 4 into 4 equals 64. The radical sign, radical sign, this is the sign placed over the number, is used to signify a root. If only the radical sign appears over number, it means you must calculate the square root of the number beneath the sign. A number square's root is the root of the number multiplied by itself, which equal that number when a root other than a square root is required. An index number is placed outside the radical signs, right? So for example, the cube root is 64 is expressed as a 64 square root of 3, right? Equal 4. Another way of indicating root is by showing the root of a number is by showing an exponent as in powers. In the case of root, however, the exponent is shown as a fraction. The cube root of 64 can also be expressed as 64 to the power 1 upon 3, even 6 to the power minus 3. The square root of 16 would be expressed as 16 to the power minus 2, right? Okay, so that is the roots. Okay, so that is the end of this lesson. So today you learn about the introductions about the arithmetic and the arithmetic terms and direct numbers, what are the direct numbers and factors, and what are the factors, and how to add, how to multiply, how to subtract, how to divide, and arithmetical procedures, fractions, and what are the fractions, how many fractions are there, how to divide, subtract, multiply, and decimal fractions, how to add, how to multiply decimal fractions, weight and measures, what are the units we are using for weight and measures in the aviation, and ratios and proportions, how to make the ratio, and averages and percentages, how to calculate the average, how to calculate the percentage, and powers and roots, and also how to calculate powers and how to calculate the roots. All right. So all right. So that is the end of this lesson. So I think you get some knowledge about arithmetics. And this lesson is the lesson number 1 belonging module number 1, mathematics. So if you are looking forward to do Easa modules, so just go through this video and then you can get a roughly idea, and also then you can apply for Easa examinations, and then you can pass very easily. And in future, and every module, after finish every module, I'm planning to do like a discussion, like question discussions, so then you can join for this video also. So don't forget to subscribe my channel, and don't forget to like, share, and if you have any questions, comment in the video in the below. And yeah, so let's meet in the next lessons related to the Easa module 1, mathematics. So next lesson I'm going to do is algebra. So let's stick with me. So have a good day for all of you, and we will meet on the next lesson.